The last category of integral that we'll study for section 8.3 involves products of sine and cosine functions. We're not talking about powers of sine and cosine. This time we're going to be talking about a sine and a cosine function that has different arguments. To handle this situation, we're going to use something called product to sum formulas. Now, I know that we have learned 6 new formulas in this section. We reviewed countless other, both calculus and trigonometric formulas. So here I've got a list of 3 more formulas, but rest assured it is not necessary that you memorize these formulas. These don't pop up enough to justify you memorizing these formulas, but do know that these formulas exist and where to find them and when to use them. So notice on the left side of these formulas we've got products. So we're multiplying a sine and a cosine and a cosine, or a sine and a sine. But observe we have different arguments. We have an alpha and a beta. On the right side of our formulas, we have 2 separate trig functions separated either by a sum or a difference. So we're going from a product to a sum. If I can split the product into a sum, then I can certainly integrate term by term. So let's see if we can choose an appropriate formula for example 8. We have the integral of cosine of 4 theta times sine of negative 2 theta d theta. Now, if those 2 arguments were the same, then a logical choice would be to let u equal your sine function, du would cover up your cosine function. But that's not a possibility here because, again, we have different arguments. Math requires you to look at all of those excruciating details. So we're going to apply a product to sum formula. Again, we have cosine times sine, so this middle formula will be appropriate. Now, looking at the details of our problem and comparing it to the product to sum formula, notice the sine and cosine are out of order. So we simply need to recognize that alpha is going to be the argument of sine, beta is going to be the argument of cosine. One way to really simplify this process is I'm just going to flip those 2 around and write it as sine of negative 2 theta cosine of 4 theta d theta. Again, I'm doing this for the simplicity of recognizing that the first argument will be alpha, the second argument will be beta when we expand into a sum. So applying the sum form, the product to sum formula to our integral, notice we have this coefficient of 1/2. Let's go ahead and factor that in front of our integral sign to make life a little easier. Then our integrand will be sine of alpha plus beta. That's going to be sine of negative 2 theta plus 4 theta. Then we have plus sine of, this time, alpha minus beta. That is negative 2 theta minus 4 theta. Simplifying the arguments, we have 1/2 times the integral of sine of 2 theta plus sine of negative 6 theta d theta. Now let me throw a couple more trigonometric identities, the even and odd identities. Sine of negative theta, since sine is an odd function, is equal to negative sine theta. And cosine of negative theta, since cosine is even, is the same thing as cosine of theta. So I am going to choose to use this to simplify sine of negative 6 theta. Since sine is odd, we can extract a negative. So we have the integral of sine of 2 theta, let's rewrite it, minus sine of 6 theta. Now we can split this into 2 individual integrals, and that's really the point of the product to sum formulas. So we have now 1/2 times the integral of sine of 2 theta d theta. Don't forget this coefficient 1/2. We're going to distribute it to both terms. Minus 1/2 times the integral of sine of 6 theta d theta. Integrating with respect to theta, we know the antiderivative of sine is negative cosine of 2 theta, but we need to divide by the derivative of the argument. And here we have minus 1/2 times the antiderivative of sine of 6 theta, that's negative cosine of 6 theta, divided by the derivative of the argument, and we are ready for a plus c. Let's finish out by simplifying. We have 1/2 times negative 1/2. We can write that as coefficient negative 1/4 times cosine of 2 theta. Negative 1/2 times negative 1/6 is positive 1/12. Cosine of 6 theta plus c. And that completes the antiderivative. So at this point in Calculus 2, you can see we're really focusing on integration techniques. In Calculus 2, you learn the mechanics of integration, how to recognize all the different patterns and how to execute those antiderivatives. But remember, the purpose of an integral is application, such as finding the area between the curve and the x-axis. In Calculus 3, you learned how to convert it to a triple integral to find volume, double integral to find area. You'll use integration to solve differential equations, which model all kinds of dynamic aspects and real-life situations. So the purpose of Calculus 2 is to learn all of these techniques and really master those skills. So again, practice makes perfect. Hang in there, keep working, and don't give up.